Welcome to a new test and teardown video. This time it's something completely different. This is a Tucker Davis Technologies unit, and it is completely pre-configured or remodulated with all the different plugins to do all sorts of stuff. It is, as I can see, for audio speech research, and this is also what they do. They do everything from optical to neuroscience research and whatever kind of funky stuff. So I can't wait to see if this is working and what it will do, and can we do anything cool with this. There's a speaker and a volume. So at least this will do. We got some programmable attenuator. So this is just a volume, headphone buffer, right, left and right input here. And so it's almost just amplifier filter. We got some DA outputs, trigger clock sync. So serial input 80 converter. And a programmable filter, and a summer where we can different gains, and then we can sum different signals. Inverts. Interesting. Definitely audio, sound, speech research product. So this is the rear. So I believe this is a power supply and a modular frame where you have it in those sections like this. They're screwed together. We got a power and data cable like that. And there's an interface plug in here with data, command sync, optical serial and a normal serial and some power. It even says here it's an optical interface, and then we got all the different numbers on each module, and it is set for 230. So yeah, we could just power it up and see what happens. There isn't really an on-off switch, so I guess it was that way. Wow, there's a fan. And that is real loud and annoying. Oi, 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 oi. Programmable attenuator, and look at that. Mode. What the heck? So, attenuator, enter. Oi, 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 oi. So that looks interesting. Waveform generator. Amplifier frequency. Oi. Amplifier frequency, phase, DC, shape, duration, and other. It's highly advanced. Other than, oh my god, look at that. Escape. That is absolutely fantastic frequency. Okay. And if we move fast. Okay, and it can go to 20 kilohertz. It is really, really easy to use. What is the lowest frequency we can? 1. I can't wait to power up my scope and see what happens. And then we got the anti-alias filters. So that will be low pass, right? Left, right, probably. But yeah, it's definitely up and running. I just spent a little while here playing around and see if I can figure this out. So of course I could just find some BNC patch cables, and what I've done here is I take the output from the generator and I put the same signal into the summer. But one of the inputs can be inverted. So you can imagine I got an inverted input and a non-inverted input. And then the output here goes to my variable attenuator. And then it goes to my audio amplifier with speaker built into it, right? So if I push this little escape button, then I figured out that actually triggers the signal generator, and the signal generator can be set up to do many things. See, this is amplification, frequency, phase, duration, and then 500 milliseconds. But you can also say shape, enter. Sine wave is what I got now. You can download a wave to it. Unify Gauss. Okay, let's say Gauss. Then it's just let me crank up the volume. So when I get an inverted signal and a non-inverted signal, that means if they're exactly the same, then I get no signal, right? So if I lower one of them, look what's gonna happen. Isn't that funny? I can find the sweet spot. And I get nothing. And then it goes up again. So this is the Gauss noise mode. I haven't tried yet those low pass filters. And there's another filter here that's also called a programmable filter. But I haven't figured out exactly how to program it because it's just low pass, high pass. What is that? G bandwidth. Yeah, but you can't change. I tried everything here, right? So select this, and then it's off. Aha! Here is the frequency. Bingo bongo. Haha! We found it. So that will actually be funny to play with, together with the noise. Okay, then we got this stereo analog interface with analog inputs and digital DA outputs. Okay, so that is digital to analog and analog to digital. Well, and then you can select the different. I think this has something to do with the serial interface on the back, and we don't have any software for it and all that kind of stuff. But I think we played enough with this unit from the front. I think we should try and look inside and see what is going on there. But this fan is really funny. I don't know if you can hear this, but it's loud and weird, and I don't see any holes. So where the heck is this fan? Sounds like there's a motor spinning around in it, and it's using 33 watts, by the way. So that is quite a lot. That was not as easy as I thought. I tried to remove the screws here because I wanted to get into this module first, because the level pot meter here is actually loose, so I wanted to fix that. But I can actually get it a little bit like this, but I think there's a connector or a back plane connecting to each of them somehow. I just need to figure this out. I was right about the two parts, so I could just unmount the first one, and they're only connected via this power cable here. So I think if you stack more modules, this cable could just continue here and goes to more and more and more. So it's super easy to expand this system. So that's great so far. Here is how it is done. I took the power supply off first. Oh, we got a date. 97. By the way, if you see the connectors here on the back of each module, let me put back the power supply. Oh, difficult to do with one hand. Come on, man. Like that, right? So you can imagine when I take out those screws, because of the way this connector is angled, I was trying to pull it up and I couldn't see what the heck was preventing this thing from being pulled up. And I didn't figure out that I needed to pull it this way. So to get that information, I took out this blind. And then I could see, aha, that is the system. Okay, this is how it's working. And then it was super easy. And here is the fan that is creating all this annoying noise. And this power supply is actually quite powerful. 5 volts, 3 amps, and plus minus 15 at 0.8 amps. And it's really, really heavy. But I guess it's because it can power quite a lot of those modules. So this is the ADDA fantastic module. Oh, it's many layers with a lot of cool stuff. While the others, that will just be some op amps and cymbal stuff. That will be the loudspeaker amplifier. There's only one little IC there or something. So I will try to see if I can get this out somehow. I think I already took out some of the screws that I was not supposed to take out, because I think the whole idea is this PCB is connected to the front and then you take it out in one unit. I really like this design. It's super modular. You can swap those completely as you like. So I got the audio amplifier with the little speaker out. Oh, I moved the speaker a little bit, it looks like. Maybe I need to loosen those screws and center it a little bit better, because that don't look beautiful. But here is the little amplifier chip, and here is the pot meter I wanted to fix. Like you can see here. See? That is loose. I want to fix that. And to get this module out of this box, you need to pull it out and then get it out, right? But that is not possible, because when you move it this way, the top of the PCB here, this little part here, prevents it from getting out from that bend here. And this is how they've done it on all the modules. The PCB is intentionally made too wide, so you can't get the boards out. If you cut those boards, it will be a million times easier to get the modules out. That is definitely a big fault in this design. And when you move this up and down, to finally figure out that you can also get it this way up and then get it that way down, it is just too small to do this. So you need to go up and down a million times to finally wiggle and fight. It takes a long time to get those modules out. What the heck? Why is it intentionally made to be difficult? That I don't get. So this is the programmable filter, and just took this out. And what do you think about that? It is packed with good stuff. And here's the really sexy display. It is highly advanced for 97. I think I can't easily take out the PCB here because of the BNC connectors. They're soldered into that board, and that will prevent me from going all the way in there easily. And I really don't like to break this, because those modules here, they can really be reused for all sorts of cool things. And I got a buddy who's doing synthesizers and music and all sorts of analog and digital sounds, effects and stuff like that. And he can definitely use those modules to combine them into his own thing, and because they're super nice and compact. So that is a great little module. See, this is the summer, which is just a mixer really, with some op amps and some invert module. And that is definitely what it is. If you look carefully, all you find will be just some op amps, not a lot more than that. But what I realized as well is that all modules got actually date codes. So this is from 2000, and that one was from 99. I would assume that is what that means. It looks also like a 94, but it cannot be. The power supply is 97, right? So maybe that is the oldest. And then you buy the plug-in modules, right? For your use. Yeah, let me see a few more. This is the programmable attenuator. Here's a fun thing. See those two trimmers? That one is on the back, so you can't access it from the top. That's a little bit funny, isn't it? But this is also full of analog circuits. But there's also a microcontroller handling the display and the input and all the programming and stuff. I can't see exactly what type number that is. Because I really don't want to pull this apart because of the BNCs soldered into the PCB, and I'm definitely gonna break away some. There is a potential risk of doing that, so no need to do that right now. I think we get the smell of it, what this is all about. Quite nice design. I don't know why I was yelling and crying about this being difficult. I think 99% of the problem is I was doing it wrong. I am now a super expert in inserting modules into this. If you do this right, it is so easy. And I think I've perfected the way. See, this is up, this is down, and then this way first, and then this way, and then this way. And then wiggle a little bit, and then they go in. And it's actually the same when you want to pull this out. Don't just yank it this way, because when it releases from that connector, it's just going to say smash, and then you have loose components all over the place. So again, you take it carefully and flip it a little bit like this while you see, and then up and out you go. So it's this secret trick there is to it. And if you do this wrong, it's not coming anywhere. So this is the waveform generator. And it's looking exactly like the programmable filter. Yeah, I could definitely take this apart and have a little look. What do you think about this? So here's a wire on the PCB layout. It's just way too close. I mean, this is not how you do that. You need to know the sizes of your screws or nuts or whatever, and add quite a lot of safety clearance, and there's plenty of space on the PCB layout. I mean, this is very amateur kind of. Not how you do that. So this is the waveform generator. Inside I took off the other board, and I think it's easy to see that this top board is more or less the same. So we also got this DSP And then we've also got the EEPROM here and some I/O chips, and then the I/O chips driving the display. And then we got a link from this module to the waveform output part. I mean, they use 2 individual DSP201 to make one waveform generator for 20 kilohertz. That is how it is. So this is the software for the waveform generation. And here we got a Burr Brown DSP201 JP. So this is a 16-bit or 18-bit digital to analog converter. Those are actually really, really good. I expect this to only be 8-bit, but no way. They made it really, really nice. Oh, that is some sort of a like. I was surprised. I was really positive surprised. So here is the AD and DA module. I mean, see, this is 1, 2, and then 1, 2. So they are probably connected together somehow, right? And then we got trig clock sync, and that will probably be output so you can synchronize to what is coming here, right? And again, it is a stacked construction, and I believe that will be some converters or analog parts, right? And there is the same DSP, and we got EEPROM for it, and a nice crystal. You can almost read. No, you cannot. Let me try and take this apart and see if we can see whatever that is. So here it is. We are inside. See, that will be some fast clock selection thingy. This programmable gal is probably doing chip selects or some handling. And then we got a DSP202 and a DSP102. So that will definitely be all the analog stuff. We got some op amps as well. Really, really well made. Just except for that little that is funny, isn't it? We got a little bit of hand soldering. That is also a little funny way to fix some stuff. Oh, by the way, I figured out what that part is. Well, that is static RAM. And then there is a line driver for 8-bit memory interface for that one. So yeah, we can definitely store and sample and play back some samples. I think that was the rest of the modules that I found interesting to talk about today. This is the interface module, and I think there's a reason for this to be mounted here. I believe the sockets you see here in the back and the front, those are connected together, so when you put in a module that requires some sort of a back panel or extra connectors, extra features from the back, then you just plug in this module on the back and the module on the front, and then you have everything you need in between here. So, and this is of course the serial interface, data and command and sync and RS-232 and all that kind of stuff. And this is of course for the AD and DA. So without that, you can't use this for anything at all, that module. That is a shame, because I really like to play around with 16-bit and 18-bit cool converters. Those Burr Brown parts, they are really, really good.